Who out there has messed with 3JS before or even heard of it? Right, get a raise of hands. 3JS, 3D library for JavaScript, WebGL. Got one hand out there, cool. How many of you are React developers or have experience with React? Cool. Okay, so this is actually the perfect audience for this talk. React Refiber is a React wrapper for a WebGL library called 3JS. It's what's used to make all sorts of 3D websites and things like that. It's a really nice abstraction over WebGL. And yeah, let's go through. Before we go into it, I'll show you some things that have been done with it. This is a portfolio website that's made with it. It's got a lot of cool effects. It's interactive. You can look at the projects. You can scroll around. All sorts of stuff here. It's like a lot of stuff going on. It looks really complicated. It looks like, oh, how could I ever do this? This is actually just all 3JS. It's all JavaScript. There's no WebAssembly in here. It's nothing super crazy. There's another example over here. We can go in here. You can even make games with it. This is all in the browser with the JavaScript WebGL API. You can scroll around. And with browsers being faster these days, you can really do a lot of stuff. You know, they're very performant. You can make them very interactive, things like that. So, and what I want to show you today is that with React Refiber, which is just a React wrapper for 3JS, you can do this sort of thing very easily and write a lot of code, or sorry, not write a lot of code and build a lot of functionality with just very few lines of code. So before we get into it, I'm gonna go over like a little bit of a crash course over how 3D rendering works in the web. Like I said before, React Refiber is just a wrapper around 3JS. WebGL is actually the low-level JavaScript API that is used for this 3D animation. That's composing of two things. One of them being JavaScript, which is like the assembly language, which you use instruction code for. And then you've got OpenGL, which is your C-like low-level shader language, which is doing ray tracing and things like that. That's a little bit more complicated to write. However, it's all abstracted away, luckily, by WebGL. And we don't have to worry about it at all for 3JS, which is really nice. But that's actually run on your client's GPU. We don't need any sort of libraries or anything, any plugins or anything. It's just already out of the box standard with current browsers. The building blocks of 3D rendering really they're all contained within this canvas component. So it's just an HTML5 canvas, which is pasted onto your HTML, whether that be anywhere in your web page. And from there on, a renderer, in this case React Renderer, will take a mesh, which is just objects in a scene. Think about a chair, like a mesh, a scene, which is like this room, and then a camera, which is like your perspective of the room. That's what creates this 3D kind of environment. And then there's lighting, which gives it that depth and things like that. For the purpose of this talk, there are other kinds of cameras, like orthogonal cameras. We'll just be looking at perspective cameras. And we won't be doing too much with intense lighting, but I just want to get you the baseline down and show you what React Refiber has to offer. Okay, so in terms of meshes, those are just shapes that are composed of two things. Geometries, which is like a chair is, I guess, a chair shape, right? And then material, right? The chairs here are made out of metal and some sort of fabric. You could specify the same thing in React Refiber or in 3JS or any sort of WebGL renderer. 3JS comes with a few standard materials, that being like a mesh basic material, which is non-reactive to light. It just, the entire surface reacts to light equally, whereas like a mesh Lambert material is a little more interactive with light, and a mesh Phong material is like the most interactive. There's also a mesh normal material, which is kind of a developer's material to see how light would bounce off of that object. But from there, it's not really used in actual websites. The coordinate system, if you have a background in math, then you'll probably notice this, but there's something a little bit off. The y-axis is actually pointing up in 3JS. If you come from a math background, you'll probably think the z-axis is going up. The z-axis positive actually points in your direction, so the user's direction, and it's 10 units away from you. You can place things anywhere on this object with vectors. In 3JS, you need to specify a vector 3 in JavaScript. Here, we can just say, give an array of three things, x being the first argument, y being the second, and z being the third. And you can just place any sort of object down based on those three coordinate points. Okay, lighting, that's another really important thing. That's what gives it that kind of depth effect, right? So you want to take your scene and you want to light it up. However, you need to specify a couple things about your lighting. First of all, is your lighting going to be casting shadows? If not, it's going to be fine. You're not going to be worried about performance. It's like everything's going to be cast the same way. However, if you do decide to subscribe or opt in your light component to be casting shadows, then it's going to be starting to use these shaders, which is going to do ray tracing. It's going to be like recursive functions which do all this. It's really kind of an intensive computation. However, it does give it that kind of nice look here. As you see, we've got a spotlight looking down on this cone, and then this object also has to opt into this light to cast and receive shadows. So why use React 3 Fiber, right? If you've seen 3JS before, you've seen people have done lots with it, but you don't really understand why you would use React or what it does better. I think what you'll really see here is that the ecosystem surrounding React 3 Fiber is huge. It opens you up to that ecosystem. You can use reusable component libraries and things like that in React and other sorts of things. And it's also a great abstraction for the 3D space. It's a hierarchical component structure. It makes it really nice and organized for your things, and you don't have to worry about a ton of reused code or a ton of repeated code when you're writing out these scenes. Yeah, and then you'll see it's just React 3 Fiber takes a lot of 3JS, like the options, and abstracts them away from you. You still have the option to change them, but you can just go through and say like, hey, I just want a canvas component, and it'll set up a camera for you. It'll set up all sorts of things. What you'll see here on the right is your standard 3JS setting up a scene. You've got to create the scene, the perspective camera, then you've got to create the renderer. You've got to add that all to a div or whatever HTML element you're appending it to, and then you've got to put it all together. And then it's very imperative. It's not easy to write. It's a lot of repeated code. Whereas on the left side with the React 3 Fiber, it's just a declarative approach. Just say, hey, I want a canvas component, and I want a box within it. In this case, just a mesh. And then you define the geometry of that mesh, and then also the material of that mesh. And then the ecosystem, I'm going to be going through it today. This is going to be mostly a live coding talk, just kind of taking you guys through it. But we're going to be looking at what the ecosystem has to offer. Like, for example, GLTF-JSX, that's a helper library that takes, with command line tools, that allows you to take in a GTLF file, it's a hard word to say, and you can just scaffold a React component directly from it. Dre is a huge, huge library of helper functions, components, all sorts of things that'll get you right off the ground in your React 3 journey. There's also React 3 Canon, which is physics-based hooks, and you can make reactive physics objects very, very easy in React 3 Fiber. We'll also look at React Spring. If you guys have worked with React some, you probably worked with React Spring. It works just the same in React 3 Fiber, except instead of CSS animations, it'll do the same with the shapes that you defined here. And then also Leva, which is GUI controls, so you can organize and space the things where you want them to go. But anyway, let's get into the live coding. So right off the bat, can everyone see this, by the way? You guys good? Cool. Okay. Oops. So let's take you to the main function here. This is all we're doing. I've got my div that I'm putting this in with my animation CSS class. And then I'm setting up a camera, and I'm positioning this camera 40 units at the y-axis, and then 50 units away from the z-axis. I'm also opting in the canvas to shadows. It's going to be a little bit less performant, but it's going to be able to show shadows and things like this. Also, there's a lot of things that need to load in, especially if you're using GTLF loaders. So it needs to be wrapped in a suspense tag, so you have some time to get that all in there. Okay, yeah, let's get into it. So the first thing is, we've ever seen here, we need to just declare some light, right? Let there be light. So let's say an ambient light, and we'll give it an intensity of 0.5. GitHub Copilot will be writing my code today, so if you guys want to sue me, please wait till after the show. All right, and so we've got nothing in this scene yet. It's just an empty screen. We need to add some stuff to it. The nice thing about Dre is that we can just create a background. So let's add in kind of a background that Dre brings in. It's just called sky. And there we go. You can kind of see some stuff. We can't really explore it, right? We want to kind of look around and see what's going on. So we want to add some orbit control, so we can kind of go around our scene and see what's going on in there. And there we go. Now we can zoom out. see what's going on. That's all there. It's kind of cool. So let's do something next. We'll add a shape into our scene. We need to declare a mesh and then add some stuff to it. We'll call it a box. And then we need to declare a ref here. I'm going to go ahead and ignore Copilot here. It's got a lot of opinions about what it wants me to write. But we're just going to declare a ref to interact with our box if we need to. And then we'll just return this mesh. And we'll declare it a position 0. It wants to make it size 1. I'm inclined to agree with Copilot on this one. Where it's attaching the geometry to this mesh. We don't actually even need this line. This is unnecessary. And then next, we need to declare our material as well. And it's going to want a hot pink material. That's pretty cool. We'll do that as well. All right, let's close our mesh tag, and we'll see it loaded on the page. Oh, but I've declared my ref wrong here. There we go. And we need to, of course, bring it into the thing here. And there we go. We've got our little box. It's not really that 3D, but we're looking around there. And it doesn't have much depth to it, but it is a box. We've declared one of those. So let's give it a little bit more depth. We'll make this a little bit larger as well. Okay. So the first thing we're going to do is let's create a point light. Point light's just a single source of light which emits light in all directions, whereas ambient light just coats all surfaces with the same amount of light. A point light emits light from a certain position within the 3D experience. So it wants to do it at 10, 10, 10. I'm going to change that to 5, 5, 5 here. Just a little bit too far away. Okay. Now, we've got a little bit of depth to our box here. That's just a box, you know. You can do this in 3JS or even with about 300 lines of code in WebGL. But right now we've got a background, we've got a box, and we've got some lighting with just, you know, very few lines of code. Okay, so now we want to make this box do something. So we need to subscribe this box to the render loop. Every single frame within this canvas component at the refresh rate of your monitor can be updated. You can update the state of this box, whether the location, the position, the size, the color, anything. It's all available via this use frame hook, which is exported by React 3 Fiber. And we can say it's going to want, right here, Copilot's wanting me to change the rotation and the of the X and Y axis. We do that here, we'll see it start to move. Let me make this a little bit more readable as well. Okay, we've got a moving box here. So where does React come in? Where does it really make a beneficial, where does the benefit of React come in? So let's add a bunch of boxes. Let's reuse this box component. We'll call it a box group here. And then we'll use just a return. And we'll return inside of these tags here. Yeah, there we go. We don't need an index though. We'll just return a box with a different position. I've got this array of positions up here. And then we need to destructure positions up here. And then we can update the position to be whatever we're passing in. Cool. Now we just need to put this box group inside of our components. And there we go. We've got a group of spinning boxes. Look at that. Beautiful. We could do more. You know, it's we just map through the boxes and reuse that component. But we can actually take this group together, and we can say we want to move this group as one unit and use another ref. There we go. So we'll declare a box group ref. And then we're going to use the frame and subscribe this entire component to the render loop. And yeah, we'll just say that whole thing. We want that whole component to move. And let's add this ref to the group. There we go. Now they're all spinning in unison in a circle. We've got a spinning group of boxes. You can expand out in there, you can go in. You can do whatever you want. I mean, there's all sorts of different exports in these boxes. They can go in any direction. You can set them equal to the movement of your mouse. They can follow your mouse. Oh, go ahead. What'd you say? Zoom out? Oh, you can keep going. It'll take you out of this, yeah, it'll get upset at you. There's a certain render distance of your entire scene. So if you go past it, it'll just say there's nothing there, just for performance reasons. But the nice thing about that is that if you want to create like endless loops or endless traveling through your scene, you can it'll unmount everything that's not rendered for performance, and then you can just keep repeating different things. And you can do that ad infinitum. But yeah, so we've shown you kind of, what's going on with just the standard use frame and like the different hooks that React through Fiber exports. But what's really interesting about the ecosystem is actually Dre and use Canon and the different things there. One thing that's really nice as well is use Leva. Leva is am I exporting it here? Oh yeah, use controls. So if I wanted to say for each of these boxes, I wanted to specify their color in and then I can set in here, I want to say we would need to export color like this, and there we go. And that will give us a box with a color. We can use this color, and you can change it like that, and then it will be reactive to whatever we put in here. So if we say we want this color to be equal to whatever color we're feeding in over here, reload the page, now these are white. Very cool. Leave. There we go. So we didn't need a callback there. And you could change this color as you'd like. Same goes for size, if I wanted to add another thing. Or scale. Just make it 1 for now. We destructured over here. If I wanted to say the scale of this object is a certain thing, and change it based on what we're trying to do within our Leva controls, you can change the scale as well. This is really nice. If you're not even just using it for React through Fiber, you can use Leva in your current React projects. I find it to be a great tool, especially for like CSS styling. If I'm doing any sort of trying to get things right in the right position, it's a great tool. So it's kind of something I'd recommend, just period. But we can do more. We can actually create a physics environment based on the materials and shapes we have right here. So the first thing we need to do is we need to bring in the physics constructor, or the provider, from React 3 use Canon. And this will give us a provider that we can subscribe our components to via refs. So we want to subscribe our boxes to it, and we'll comment all this for now. Create a new ref. Give a scale here, and color. Make this hot pink again. Let's see what we got. Ref is not defined. Right here. Okay. We'll create a new ref. So use Canon exports this function called useBox, which takes in a callback, and that's where you specify the different parameters in this physics environment for this box. So we want to say, create a useBox, and we want to give it a mass of 1. That's something we can do. We don't need a position. We can put it in either place, doesn't matter. Either it goes in as the ref or it goes in via this prop on the mesh tag here. So there we go. Now our boxes are falling to the ground. Let's go and zoom in there. And there we go. They are now subject to gravity. And you can change the parameters of gravity right here. So if we wanted to make it very small, -30 is pretty extreme. We'll make it -1 right now. Okay, there we go. Now it's going to fall at a very slow pace. So we need some sort of plane to catch these objects. We'll define a plane class or a function here. GitHub Copilot apparently already knows what I want to do. It's reading my mind. This is what I want to write, so we'll bring it down right here. Because the plane starts out at pointing up in the y direction, we need to rotate it 90 degrees based on the y-axis, which is what's going on right here. So over the x-axis, it's being rotated by 90 degrees, and it's exporting a ref. It'll also export an API, same as use box. We don't need it for this one. So we can just return a plane, which is another thing exported by Rack 3 Fiber. And it'll just give us everything we need here. This plane is going to be 100 by 100 units, which is going to be pretty massive compared to everything. We don't need a shadow material. We'll just make it a mesh standard material, or mesh font material. There we go. And we'll make it gray. Okay. Cool. We need to bring it into our scene now. And there we go. But, oops, they are heading in the wrong direction. No, they're coming back down. Okay, so let's bring the plane down a little bit for the position, because I think that they're spawning on top of each other and getting shot up for that reason. All right. Yeah, there they go. They've landed on the plane. Okay, let's take the position here and we'll set it equal to -10 or -1. See, the same thing happens. Still happening. Let's try -5. They're just being launched up, you know? I guess we'll just let it happen at this point. Why not? We'll just increase the strength of gravity so they can come down faster. All right, cool. Now they're only popping up a bit now. But awesome, we've got some physics going on now. It's pretty nice. We don't have to worry too much about, creating hitboxes and things like that. If we just declare a box and we just declare this use box hitbox, same for the plane, it'll automatically generate a hitbox for us that's reactive to physics. There's a new library coming out. It's under heavy development right now called Rapier, but it's really interesting for creating hitboxes based on the material you give it. So if you give it a very complex geometry, it'll create a hitbox basically immediately for that. It's really cool, and it's a lot going on. If you could look at the repo right now. If you're going to deploy anything with it, it's probably risky because the APIs are still subject to change, but expect big things from there. Okay, so now we're looking at our physics environment, and we want to interact with these boxes. We want to unclick and different event handlers. We want these boxes to do something. So let's set gravity to 0 real quick. And let's remove our plane. And we just want to move these boxes on some sort of onClick function. So this API will give us some sort of API to interact with this shape. So if you wanted to add let's call it a bump function. We want to bump this thing here, and it's going to say, it's wanting me to set the velocity. I'm actually going to apply an impulse, which is just a force for a very brief time. And I want to apply it at 10 in the positive y direction. There we go. Okay. And then we want to call this onClick. Okay. So I need to call it here. Can't remember now. There it goes. Now we applied the force, and it's going up high. And it'll keep going forever because there's really not much gravity here. But we can add a little bit of gravity back into our scene just so it doesn't fly away completely. And decrease the value of our force. Oops, not 55. There we go. That's how you interact with shapes, though. Okay. So we've looked at a little bit of physics. We've looked at kind of some of the controls we can use to interact with our shapes. What about animations and shadows? Let's bring our plane back into here. And we'll kind of look into what we can do with making our scene look a little bit more like an actual thing that you would see, or you would want somebody to think that like, oh, that looks like a cool 3D environment. So we'll take this. We'll just get rid of our plane here altogether. There we go. And bring the plane back in. Oh, we need to bring back our rotation though, so let's bring back this ref. There we go. Cool. We'll take away the physics as well. We don't need it right now for our box. Okay. Cool. It's just going to go through that because it's no longer part of the physics environment. We did the same for our box and the ref. So we'll take away everything here. Bring back the position. Bring our ref back, just being a normal ref. Go. Okay. Get rid of this function because that's going to throw an error as well. We've got our stuff back. Just a plain old, nothing going on, box in on a plane. So we want to make these boxes reactive to light and cast shadows and receive shadows. The way we do that is we need to change this from a mesh standard material to a mesh fog material. Okay. And then we need to say these can cast shadows and receive shadows. Same goes for our point light. These to cast the shadow, and there we go. Now they're casting shadows from the direction of this point light. And we can actually bring in, so if you have a GTLF file, there's a really cool place called Polyhaven where you can go to. And you can bring in your own GTLFs. They have a ton of free stuff here. If you want just like models, for example, the one I brought in currently is a fire extinguisher. And you just download this as a GTLF. And then go into your component. You say, okay, I want to scaffold a new React component. We'll just take my current one, this one right here, and copy the relative path. And then we want to say it's reactive to shadows as well, so we'll bring in the shadows flag. That'll just create a completely new React component that we can just put inside of our function. It still needs to be imported. I've actually got it. I can import it up at the top. So we can just delete this one. bring in the one I already have in my app, which is right here. So back to our scene. I'm importing it. You can see right here. So fire. And there it is. Just a fire extinguisher hanging out in space. Not doing much. We can scale it up a bit. And because they're just spreading the props currently into the group, we can just say it's a specific size. So we'll change the scale of it. Well, just saying the scale is equal to scale is not really doing much for us, is it? We gotta actually specify something here. There we go. It's a little bit bigger now, kind of hanging out, and you can see it's also casting a shadow with the rest. So if you wanted to take this, you can and make it reactive to the physics state. You could declare a hitbox for it using useBox. This is pretty boxy, but if you really wanted to get deep into it, you could declare like, hey, I want to use wrap here, and I want to declare a custom hitbox for this shape, and it'll instance it based on the geometry of the shape itself. It's really cool stuff. But let's say we want to bring in another library called uSpring, and we want to have these be reactive to reactive states. So use the actual React part of things. It would change the color based on whether it's been clicked or not, for example. We can still use state just like you can in React. So we can say hovered or clicked, maybe would be a better term for what we're doing here, and use clicked. Try to follow some React best practices here. And then we'll create a function. So just equal to use click or clicked. And then we'll set a ternary for hot pink or light blue. Sure. And we'll set that equal to color. Okay. So now we just say on click. Declare a little function here. And we can just say set clicked to whatever the opposite of the current is. This is kind of getting messy here, but yeah, let's subtract the space here. There we go. And now we've got a reactive thing based on state. I will say that if you want to do very quick changes to state, use refs. You should really only use things like state for click handlers or event handlers. Otherwise, it's going to be very slow. For example, if you use like a useState update inside of your useFrame hook, it's going to be updating way too fast. And it's going to give you a lot of performance issues. I think React 3.5 will just throw an error because it's not going to be able to keep up in time. That update state operation is like a little bit asynchronous. So yeah, don't want to mess around with that. Yeah, but I want to leave some time for any questions if you guys want to see anything in particular. Go ahead. Yeah, so right now, if I brought them in fact, we'll bring in the positions. We'll map these positions a certain way. Call this map positions or something. And then we'll just go through each of those. If we don't need this, we'll just destructure this. We'll call it, I don't know, dx, dy, maybe dz. And we'll just say that for each of those positions, we just want to say that the new array is going to be x or dx plus, current dx plus maybe multiplied by some constant we can change. We'll just say 2 for now. And we'll do the same for the rest of those. And we'll make this constant something we can change. So we'll use the use controls again. Const. What should we call it? Maybe distance. Distance. And we'll make that just 1 for now. You can pass in a couple different things. So they'll give you, right now for like Leva, you could either just pass in a value or you can pass in an object, which gives you some different ways you can alter that object. So they want to give me a different step value. I don't need the min and max. We'll just create the step to be 0.1 though. And the value, we'll start that off at 1. Okay. Distance value. Okay. And we'll make this distance instead of 2. We'll call this map positions. That's what we'll be mapping through. Okay, what's the error now? Positions is not defined. Should not be anymore. What line are we on? 49. I spelled positions wrong. There we go. Cool. Now we've got our distance we can change. And if you just bring them closer together, let me get that. That's probably way too small, isn't it? Hold on. Right now, nothing will happen. They'll just kind of hit each other. But if you make these physics-based objects, if you subscribe these components to the physics environment, so let's do that again, they'll like expand outwards and explode, basically. Okay. So let's get rid of all this. Let's call this positions again. And then we'll say, make the new ref and the API as a use box. We'll give it a mass again. And position to position. We don't need to do that. The position can be wherever it is currently. It's working just fine. We'll close it all off. Okay, and I believe I need one more of these. Yeah. Bring it all into one line. Okay. Is that throwing an error? There we go. So that's what happens. You can't see it because they all start kind of the same place, but they'll explode outwards when they're in this environment. Yeah. Yeah. Any other questions? Go ahead. You mentioned like augmented reality also like on the slides. How important is that? Augmented reality? So there is a, if I go back to the slides here. Yeah, React 3 XR, which is like the library to help you create experiences for like an Oculus or something. I haven't messed with it personally. I know that it's pretty big in the community. A lot of people are using it for doing cool stuff like in the metaverse, you know. If you guys want to make billions and get your plot of land out there, it's a good time to do it. Yeah, it's a cool thing to do. They also have use gesture if you want to use it on your phone. You could also use, because it's just React, the same way that React Native works for mobile phones, you can just use React 3 Fiber on a mobile platform. And you can use things like use gesture, which is a thing down here to interact the objects to your touch on your phone screen. There's no reason you can't do it on any platform that supports React. Even Electron, for example, if you want to make like a desktop app, you could bring in a React 3 Fiber project into that sort of thing as well. So that's all doable through this platform. Yeah, anything else? Cool. Thanks, guys. What'd you say? Yeah, I mean, this is the one I was bringing in here. It's mostly for like cool landing pages, right? So if you have a current React app, you can drop this canvas component into basically do whatever you want. Whether it's like, for example, GitHub doesn't have it anymore, but their old website used to have a spinning globe, which you can go and you can interact with. That's React 3 Fiber or 3JS. For example, this guy's, if you want to make a really cool like portfolio page, this is just some guy, model some guy made in Blender, uploaded via like a GTLF file, and then used a library called React 3 post-processing to make it like the lights look really cool. You can take objects and make them emit light and things like that, as well as make it interactive. But yeah, that's the sort of thing you can do. If you want to create a website with any sort of interaction, maybe you want like, there's a cool one where like somebody's like, there's balls that'll follow your mouse when you're scrolling through the screen. That's something that people have done before. You don't see it that much because I think people think it's a lot harder than it actually is, right? I mean, we only written maybe like 100 lines of codes today, and we did quite a bit of functionality, right? I mean, it's very accessible. The community's great. You can check out the Pomander's Discord channel. People there are very nice. They'll help you out with any problems you run into, and there's a lot of code sandboxes for you to look at examples on. It's a great community. But yeah, I'd say the biggest probably real world implementation of this is landing pages for companies and things like that, or product demonstrations. You'll see it a lot in the retail space where people will have like maybe a bag they want to show off. I know like I think Gucci has a website where they have a bag that's uploaded to the GTLF model and it's shown off that way and you can interact with it and things like that. So yeah, it's cool stuff going on. Anything else? Go ahead. Yeah, so this is, you can, maybe if you want to declare like some sort of HTML element that can handle like a video input, you can, within your React 3 Fiber code, it's another export from Dre, you can just declare an HTML space. So let's say within our canvas component here, we just want to declare HTML. And then, yeah, they want a container here, why not? Give it an F1, yeah, sure. Okay, close it off. And now we've got some HTML we've written in here. You can make it interactive. You can also you can bring in a component library, Tailwind CSS. You can do it whatever you want within here. And it'll just be splatted on top of your React 3 Fiber or wherever you want it. There's also different exports for centering. Somebody made Flexbox in React 3 Fiber, which is pretty cool, but you can create like a Flexbox and a grid within your space if you want to organize your HTML that way. So if you wanted to create a portfolio page where you had like a physics game in the back and then like your resume just on top of it, you could totally do that. Yeah, wouldn't even be that difficult, to be honest. So yeah, cool. Cool, anything else? Awesome, well. My name is Alex Nahas. I'm not sure if I ever introduced myself. I work at Launch Scout. It's a company, a consulting agency. We build websites for other people. I'm usually a front-end developer. I do primarily React. I've been doing a lot of Rails recently. I'm not very good at it, but I've been trying. Yeah, and I do 3D stuff in the kind of on the side. When I was on the job hunt, I wanted to create like a portfolio website, and that's what kind of got me into it. I discovered the Discord channel, the community. And there's not a lot of stuff on YouTube about it. It's all 3JS. But the community is huge. It's blowing up a lot. People are building really cool stuff with it right now. And particularly React 3 Dre, which is like the community's effort to create libraries and helpers for React 3 Fiber is really gotten, it's every day you go to the GitHub page, it's increasing in what they offer. So it's pretty cool. Yeah, awesome. Cool.